enhancing the Internet of Things security in April. And there were a couple of different themes that were part of that discussion. And one of them was about increased network resiliency, but we didn't exactly get very far with that in that meeting. We spent a lot of time talking about consumers and talking about ways that they might be they might get education and the ways we might improve the marketplace. And we didn't talk too much about network resiliency. So I guess the idea here is that we'll try to pick up on that theme and figure out a little bit about what we mean by network resiliency and so on. Some of us were hopeful that some of this would be kicked off on the mailing lists, but we haven't had a lot of work, a lot of luck there. So we're going to try different ways to do this. I guess maybe what we can do is just sort of go around. The numbers are small enough that we can go around and make sure that everyone introduces themselves, so we can recognize people's voices. So why don't I start here? Well, I can just start with the things in the order in which they appear on my screen, which is probably not the order that they appear on your screen. So let me start with Tom Stark.
Hi, everyone. I am the project manager for this particular initiative, and I work for the Internet Society, so it's a pleasure to be here.
I've got Katie next.
Hi, I'm Katie Watson, and I'm Policy Advisor North America at the Internet Society, also working on this initiative.
Next, I have Rob Davidson.
Hi, I'm Rob Davidson, and I'm with the Information and Communications Technology Council here in Ottawa.
Next, I have Mark.
Hi, Mark Buell with the Internet Society.
Next, I have Martin Boterman.
Hi, I'm Martin. I'm in Rotterdam, the Netherlands. I'm involved in IoT as Dynamic Coalition on IoT chairman, and I'm interested in all these aspects to come to a sustainable way forward with IoT in the world.
Next, I have somebody called T844323's iPhone.
Yeah, sorry about that.
No.
It's Jordan Nelzer at TELUS. I'm basically in an innovation position within TELUS, and I have some projects that are looking at IoT security and trying to provide IoT networks with the connectivity they need without having them open to too much attack surface, or vice versa, able to attack networks themselves. So a lot of that is for what I'm thinking of in terms of network resilience. It's partly things like that, trying to give IoT what it needs and not too much more.
Okay, that's great. Very helpful. Thank you. I have next Amit, I think. This is the problem with getting old. The type is now so tiny that I can't really read it, but AHAMI, I think that's a T3. And if you're speaking, you're muted. All right, a silent observer. And then I have M. Gamble.
Hi, it's Matthew Gamble, Principal Technologist at eGate Networks, interested obviously in the ISP side of this and how we can assist with resiliency and security.
And we've got a couple of people, it looks like, on the phone. So I've got somebody in 202 ending with 1559. No joy, and and now no longer there. So I guess that was a disconnection. And also I see somebody in the 905 area code, final numbers 5000. This is going to be a very quiet group if we can't speak. All Alrighty. Well, why don't we start with this notion of network resiliency? And it seems to me that there are a couple of dimensions that we could talk about. And so one of them is exactly it's not exactly the network resiliency. That is, it isn't the network sort of responding to these things, but rather making sure that we don't introduce difficulties onto the network. That is, we increase the resiliency by not adding danger to it in the first place. Is that one approach that I guess that was sort of what we were just talking about a moment ago. Another way to do it is to talk about the way that the network can respond to these kinds of threats, so that if something negative for the network is somehow installed on the network, the rest of the network can respond to that and be resilient to that. So those seem to me to be two different threads and two different approaches that we can start this with. But I don't know what people think about that, and I thought I would ask whether one of those or the other is actually the way that people would like to start trying to peel this apart. I'll just open the floor. Nobody, really. I'm going to have to do all of it.
Just one more question. Is the network itself helping to protect IoT devices also open for discussion?
Yes, of course. I mean, I think that is that's a sort of third plank that we can think about. But when I think of this term network resiliency, I guess I start from the network rather than the resiliency side. But I think what you're suggesting is that we start from the resiliency side and figure out what needs to be resilient in the first place. Is that fair?
Yeah, it's somewhat fair. I mean, there's different dangers for different actors, but maybe if we're trying to solve something for one, we can also try to solve something for another as well. Have something in it for everyone.
Yes, well, I agree with that, but I think that what we're seeing is that we're having a little bit of difficulty getting started, and I guess maybe because of my sort of engineering background, my natural thing is to say, okay, well, let's pick one and try to get started in that way. So, if you want to get started by talking about how the network can protect the rest of the devices, I think that's a very interesting thing, and I'd be interested to hear what the techniques are that you think we should look at from there.
Okay. Well, I mean, certainly there were some leads in our previous session where I believe either you or someone else mentioned IETF MUD, but certainly because IoT devices themselves are quite limited. Generally, not always, but generally in what they do, it is in principle possible to have the network help them to meet their needs without giving them too much access and vice versa, giving anything else too much access to them. And whether that's through Matter, whether that's through some other policy mechanism, being able to provide just the right network for IoT. Not necessarily full internet, is probably something that can go a long way.
Yeah. So this is an important point. It seems to me that and one that I think the manufacturer usage description sort of assumes without making explicit in most of the documents so far, right? So the idea is that a device comes onto the network, and the manufacturer usage description tells you what that device should and shouldn't be able to do, what its capabilities are. And having that knowledge, then the network can respond to that by setting up sort of zones of capabilities where different kinds of devices in the system have different sorts of ability to communicate with other devices. And the idea here, basically, I guess, is that a thermostat probably doesn't need to send a large quantity of DNS queries towards, say, the root servers for the DNS. And if they start to do that, that is an indication that maybe there's something going on with it. So this is the sort of overall strategy. But it seems under those circumstances, there's an entire policy element to this that then needs to be developed in order to sort of figure out both network operation policy and also sort of profiling of how you decide what devices ought to do what thing. Because the manufacturer usage description won't help us if every manufacturer ships everything saying, and I can go to the moon and I can rule the universe and so on. And that's historically been the problem with these kind of declarations. So I don't know, what do people think about that?
So what would be the mechanism to ensure that what is said in the manufacturer manual is actually the case?
So that is the key. That's the key gap right now, right? That's precisely one of the problems that we have. And one one set of recommendations has been, we do this with reputation. That is, you have some belief that this is a good manufacturer, and so they're going to advertise things correctly. Another thing that people have proposed is a regulatory thing. That is, you have some standards body like some sort of certification authority like we have for electrical devices, and they come in and they impose these things on people. So that they're correct. Another thing that people have talked about is, kind of reputation systems like we do for email. So you have reputation systems that do a lookup. So your gateway, which you presumably trust more because you bought that from a really authoritative and good provider, how you made that decision. Once again, there's a lot of hand waving here. But you could say, fine, what I'm going to do is I'm going to have this gateway, and it's going to do reputational analysis, and then it looks at the announcement that comes from this device, and it says, I don't really believe that you're that kind of thing. There's a little bit of assurance that the device is the right one. So those are some things that people propose, but I think nobody really knows what the answer to your question is.
Right. I think one possible way we can approach this is to have more incentives for manufacturers to open source their code, and especially those ones that will be run on the premise of the consumer. And this, we may be able to achieve this by providing more government incentives to, or encouraging the government to put more incentives into this way of software development, innovation, or data ownership model, where you can pass a set of tests in your source code via a external public audit, where we see that, hey, the data is actually by default private unless the user chooses to share that, and there are clear user interface to indicate what data you're sharing to the network, and that the code can actually be audited by external parties. And also, we can fund organizations properly to do these analysis on consumer products. But perhaps because I feel IoT is a little different from say your computer or your phone, because they're so ubiquitous, and there will be so many of them that anyone can spend $10. The barrier to entry is really low. Anyone can buy a $5 chip, and this thing becomes now a connected sensor device. It's very difficult to make sure that they're all passing through a rigorous certification process that's centralized. So yeah, I just want to throw that out as a possible model.
So I think that what you've highlighted here is actually another dimension of resiliency. which is a little bit different from what we were talking about in the first place. The first area that we were talking had to do with, so the first one that we introduced was how do we protect the network, and then similarly, how do we protect the devices on the network? That is, if we're introducing if we're introducing Internet of Things devices and connecting them to the internet, how do we protect the rest of that network from those devices? And then conversely, how do we protect the devices from the rest of the network? But what you're saying is there's another layer here. I think this is what you're saying. There's another layer that is protecting the users of these devices from maybe negative consequences of the use of those devices on the internet. Is that a fair description of the different resiliency you're talking about here?
Yes, and it also does protect the network and the devices themselves when people, users, manufacturers, policy side, and researchers have more visibility into what the devices are actually doing.
Oh, I see. So the idea is that if the code were open, then it would be possible to audit the code on a device in order to tell just exactly what it really would do, as opposed to what they're claiming it was going to do.
Yeah, even from my industry experience, working with closed source software, sometimes it's really hard to guess what's actually happening to my software because I have dependencies that are doing things in a black box. So it like that sort of model does encourage unintended consequences to the network or the device themselves.
I see. I think Martin has a reaction to this. Martin, go ahead.
Thank you. No, I think, as always, you're both right. And the conclusion that the previous speaker had is that not all devices will be safe, is, I think, an important one. That brings us back to your premise, is how do we protect the network? Because even if we get new devices, and in particular the high-end devices, to be secure by outset, then we still will have a lot of devices on the net that are more low-end or are already there on the network today that won't have that. So I think we cannot escape from network providers to continue to scan for patterns and adopt an approach, maybe a la manners, but then specifically for these kind of devices, that is a habit to make sure that if they're abused or used for things that shouldn't happen, that they're cut off or diverted or whatever.
So who does the cutting off or diversion in that case?
Well, I think if network providers have a policy in which they indicate that, for instance, when a device starts to do all kind of pinging that you wouldn't expect from it, that they will cut it off, that is a good thing. But it should be a conscious process, and it should become an explicit process that is not just coming as a surprise. I think that's important too.
Do we currently have sufficient protocols and infrastructure to really protect against intended or unintended attacks from a large group of devices? It seems like we have gone through a couple large-scale botnet and like that. Those are type of attacks, and operators are very. It's very powerless when you have so many IPs coordinating against you, which would be the case in malfunctioned IoT devices. It's difficult to cut them off.
So the interesting thing about the MUD approach is that it's supposed to give some sort of information about that, right? That is, the idea of MUD is that the device comes up and it's supposed to say, this is the sort of stuff that I'm capable of doing. And what that should mean is that some other device that is sort of the security device in this network, or maybe a gateway, most likely a gateway, is going to say, well, here is the thing that is supposed to be doing. It's supposed to be doing, this set of functions, 1 through 5, and suddenly I see it performing in a way that is not in that set of functions. Then, in principle, I'm supposed to be able to deduce that that device is broken somehow, right? I don't know if it's been attacked, if it's been compromised, if it turns out that there's a bug in the code. From the point of view of the network resiliency, though, I don't care why this thing is happening. What I know is that the device is not behaving as advertised, and if you're not behaving as advertised, then something is wrong. What I should do is put you in a sandbox, or stop routing your packets, drop them on the floor, or something. I think that's the idea behind MUD. And I guess the question is that right? So then the difficulty that I see is that you need to know where that thing has to live, because in the current environment, I'm presuming that these announcements are not going to go right. That one of the large residential ISPs is probably not going to have they probably are not going to want to have a taxonomy of everything that is on their entire access network. So instead, what they're going to want to do is push that functionality down into the local networks of their access customers. And this seems to be putting quite a bit of ISP functionality inside the customer premises. Whether it be a home or a business or whatever, it doesn't matter, right? It's pushing functionality really into a customer premise. And then I guess the question is that something that we think is a good recommendation, or something that is worth thinking about, but we don't know what to do about it? Or is it something that people are allergic to? What do people think? Please go ahead.
So I'm from an ISP. I don't know. There's some thought that maybe the architecture of having as much processing in the home is not necessarily the best one. And so there's work within Broadband Forum, for example, to move some of the residential gateway kinds of functions into the network edge. So, out of the prem. But certainly for now, that's the model, and that's very few people are doing anything, or most of the generally that is the model. There's not a lot of people actually doing anything else. Of course, if it's not in the home, if it's on a cellular network or something like that, then that sandboxing function is all part of your network side. I think that if we don't sandbox, the moment a device gets infected or compromised, the first thing it's going to do is change how it presents itself to the network, right? If it wants to avoid being filtered. And so I think if we wait until there is a compromise and try to identify compromised devices, we're probably too late. So I think the value of MUD is sandboxing early rather than trying to wait until something doesn't look like what it said it was to sandbox it, because it's just going to lie.
So I'm not so familiar with the technical meaning of MUD and sandbox, but what I do understand is that of course you need to divert, and you talk about the how do you call it, the computing capacity in the edge, which potentially comes with some dangers. If we go back to the DIN attack, from which a lot was published, a lot of analysis, I think it was clear that a lot of the devices there, mainly cameras and things like that, were detectable beforehand as badly secured devices on the net. So as a network owner, you could map already where the danger could come from, and therefore be very early in detection of DDoS attacks or other things. I think that should become a standard responsibility in a way. Not in every network, the same effect would have been achieved as within the DIN network because of the architecture and the way they dealt with it. So learning from good practice would certainly, in general, get network providers to be more alert and more ahead of the problems. Next to that, obviously, there's also things that, in particular with DDoS, that you can provide joint DDoS syncing methods and equipment and tools. For instance, in Holland, there's a service that has been set up as a joint initiative of a number of ISPs that now is a kind of actor preventing DDoS to happen to any of its members. Next to providing a joint capacity, which is much more effective than a single capacity, because it's almost it's very exceptional that all its members would get attacked. It's always a couple of targets. They also collect a lot of knowledge about how to deal with this. So on one hand, I think best practice in network management is part of the solution. The other hand, it's building joint facilities to counter counter DDoS attacks would be useful. Would that make sense? Or am I too not technical?
I think those are sound all valuable, but probably insufficient, is I think the fear.
You make me curious.
I think the fear is that simply there's going to be so many different devices out there that if you've already let a bunch of them become part of a botnet, the botnet is going to win. So the more we can stop compromise of these devices, the better off we are. Not that we shouldn't have much better response capabilities when there is an attack, etc. But the earlier you can stop anything from being weaponized, the better off everybody is, and probably the easier it is.
Yeah, there is where I come from, the non-technical perspective of the market, where I see it will be very difficult to prevent computing capacity to appear on the edge and to control that. I can see certification can help to make people aware that their equipment is safe for them, but there will always be other equipment in the edge.
I think one of the key difference between how IoT devices is different from our traditional usage model of computing devices is there can be like so many of them. And the traditional approach of trying to centralize or scale up centralized infrastructure and aggregate centralized infrastructure to provide some sort of load balancing that has worked in the past most of the time may not work so well in the case of many IoT devices. So instead of thinking when we try to protect the network, is it possible to shift to a thinking where we have IoT devices that can function locally without requiring the network? Is it possible that when my home light bulbs get taken over, it affects only locally and not my entire neighborhood? So containing the threats, and also I know that the fact that my neighbor bought some very sketchy devices and got his home taken over, that will not affect my internet connectivity. Can my home devices function locally without depending on the internet connection?
Well, clearly your devices need, well, I shouldn't say clearly, in the early days of some of this, I in fact bought a gateway that depended on its connection to the internet all the time, which produced the amusing result that I had what was effectively a power outage because this happened to be in the United States. I had what looked like a power outage because Comcast had a bad day. Right, Comcast was disconnected, and this gateway just shut everything down. So I think that some of the early thinking about this was a little bit careless about those kinds of things. But I do think that people have figured out pretty quickly that you can't have the light bulbs unable to work every time the internet has a burp. So people have worked out that problem. But there is of course necessarily some sort of effect of the connectivity, right? Something is going to fail if your device has to be disconnected from the internet. Something is going to fail in that device. Otherwise, it wouldn't be an Internet of Things device at all. It wouldn't need the internet. You've got to have some things that just don't work once you're disconnected, or else you didn't need the connectivity in the first place, right?
Yeah, but we can also think of it as networked devices, and the reliance on the internet is not a always-on connection, which is actually a very suitable use model for outside of North America, where you don't always have internet connectivity. At the protocol level, we should let devices function among themselves over a local network most of the time, and then maybe batch up stuff to communicate with the servers. This way, we're not relying on a always-on connection for things to function at all, and then the network load may also be a lot less in general, because most of the decision making is done locally among my devices and not calling up to a centralized server to do all the processing.
Right. So this tends to argue once again in favor of a not really an internet, but a catenet, right? A concatenation of individual networks where what you have is a gateway for some subset of so-called Internet of Things devices. And it's really the gateway that is participating in the internet. It's the thing that talks out to the rest of, to other devices on the network. And it sort of manages the local stuff. Is that a fair description of what you're talking about?
Yeah, I think that's a good way of looking at it.
And I think that is the scheme. It's too bad we don't have somebody actively working on this protocol on the call, but I think that is the. I believe that that's the scheme that MUD is really proposing. That the gateway is sort of in charge, and it makes these decisions on the basis of the announcements. So I take the point. I forget who it was. Somebody was saying earlier. That you want to detect those things before they're infected, because as soon as they're infected, they're going to announce new capabilities. And I think that's exactly right. What you really have to have is a gateway that has this history of, I know what that device ought to be doing, and then it comes on and it announces this is what I'm going to do, and you're in the position at that point to say, I see you're claiming that you have a capability that I don't believe you should have, and I'm going to shut you down.
I think it's actually too late at that point, because if I'm really compromised, I'll just appear as a different device. How does the network going to know?
Well, the network, of course. So you're thinking, it replaces its MAC address. It replaces everything. So it just appears like a brand new device on the network.
Happy birthday! I'm something new.
Right, and I think the other idea of this, and this is actually where it seems to me there's a lot of hand waving. So I take your point exactly right. You've got to prevent those devices from somehow coming onto the network. But one way to do that, of course, is to say, here's my taxonomy of things that I believe are on my network. If something new comes on and I don't have explicit configuration in order to tell me why this thing is here and so on, I'm just not going to let it talk. I'm the gateway and I'm in charge. But then I will point out that this runs contrary to everything that we have done over the past, 15 or 20 years in network configuration where it's all, you know, autoconf and so on, and we don't actually make, you know, people configure their devices by hand anymore, because it turned out that what that really meant was that, like, all of the people who were hired in IT turned out to be their IT, you know, support department for everybody they knew as well, because nobody knew how to configure these things. So, so we do have this tension. It sounds like this is an important result, I think, of this conversation. There's a tension between the sort of autoconf drift of network configuration that we've been doing for the past many years, and the security where if a device comes on the network, you can't really trust it, and you don't know how to turn it into a legitimate device. Is that
There's
a fair description?
That's extremely fair. There's a lot of things we're doing that are not really great practice for IoT, right? Letting a device into your LAN and just, okay, great, now you can see everything in the LAN. You're a new device, welcome, we all trust you.
Right.
That's not great, right? I mean, this is part of the thing that is probably not an awesome idea when we're talking about devices that are not general purpose devices.
Well, what I find
not managed by the user.
What I find in the European IoT developments, and in particular the EU-funded research, is there's a lot of thinking in terms of cyber physical systems, which in a way also is a kind of gateway approach. But it also ensures that within the cyber physical system, things can function even when the connectivity is killed. So I can see a car, if the connection fails, it would be great if you can still steer and brake and gas.
Would be nice.
Like I'm sorry?
So, sorry, I said that would be nice.
Yeah. And in the house, you can still turn on the heating and cook, even if the network connections to the outside world are gone. Things like that. But it also connects very much to what Andrew said, the gateway approach. Obviously, whatever solution we have, and that's why I agree with Andrew as well that we may need to go to a new approach of network management. There will always be devices out there that are not as tightly managed or secured as other.
Perhaps it's also useful to think about incentives for who would be incentivized to cut you off. Like if we think about an internet model where you have more peer-to-peer connections and then your peers can cut you off, then you kind of decentralize the network management side rather than always deferring that to to your ISP, and maybe you can defer that to like a more local network provider.
Okay, so if I'm a manufacturer, I have some IoT device, and it's really only supposed to talk back to a handful of things which I want to be able to control. It's actually challenging. It's a challenge for me to have that device, get onto a LAN, have a bunch of other things, able to attack it, sideways through a browser or whatever. If I could put something on a network and make sure that the network only allowed it to get to me, it doesn't mean I'm going to let down my guard security-wise, but it is easier. It does mean it does mean that my devices are going to perform better and my reputation will be better and all of that. So I think there is value if we can make it easy for IoT devices to do their IoT, but not full internet and I think that's there's an incentive even for the manufacturer.
So I think that's an important point. But now let me ask you, which part of the internet is the part that is obviously the IoT part? Because that's been the challenge, I think, right?
Yeah, no, I understand that. So, I mean, like, I think one of the first questions is, so at the moment, everything just gets onto public internet, right? And every device, you know, the way that our system is architected, you know, in general, things can have pretty wide views. And I guess one of the questions is, you know, from an internet, you know, at the IETF level, should we be making it easier in some way for devices to basically see much more private connections?
Well, so this again touches on this idea of the sort of Catnet style of networking, right? So I don't know if everybody's familiar with this term, but in the 1970s in particular in France, there was the Minitel system there. And the basic approach there was you took different networks, and at the edge of each network, it had a connection to the rest of the thing. But once you came inside a given network, it was an internal protocol. And then once you went beyond that edge, you had this interconnection layer that was at the edge of the network. And then the next network was another internal thing that was none of your business. So the idea, you didn't have an end-to-end connection. Instead, what you had was a connection to your gateway. The other network device had a connection to its gateway, and the gateways talked to each other. And you could use different network technologies inside. The internet style was instead to put everybody into this internet protocol. So everybody uses the common protocol between, and the routers are not really gateways in quite the same sense. That is, they don't do translation for you. What they do is they merely hook up your connection at the one end at your edge, and then you hook up the other connection at the other edge, and now we figure out how to route packets between you, but you speak the same protocol all the way along. And the internet style for the past many years has tended to take over these things, right? So there were lots of other protocols. When the internet got going, we had different ways of doing these things, but IP just sort of took over. The internet protocol took over. And so the Internet of Things, in one sense, is the pushing down, once again, of this IP stack onto these devices that I think you're arguing pretty plausibly maybe are not really capable enough to be full members of the internet. They have too many flaws in them, and we just shouldn't let them on the internet. But what that really means, what we're really arguing at that point, is one of three things: either that these aren't really an Internet of Things, but it's rather a Catnet of Things that are maybe using the internet as a transport, or else what we're saying is there are these like local networks, but the internet thing goes at this gateway device and it talks the internet, but everything else is not really on the internet. And that's kind of like the Catnet thing. But the point here is that all we've really done then is move the boundary for the resilience problem, right? Because we've maybe left out the light bulbs, but now we've got these customer premise equipment gateways that are they're full service computers once again that are going to be unmanaged and all the rest of it, right? It's just like blowing up the problem of the home router that we saw back in the late 90s and early 2000s. So that's the second thing. And the third possibility, of course, is that what we say is that this whole idea is actually incredibly dangerous, that we haven't thought very hard about hooking these things up. And that's the sort of, hold back the sea approach to what we should do about this. I would like to suggest that we can rule out, as something from our discussions, we can rule out the possibility that we can just be like King Canute and like hold back the tide, because it's coming in whether we like it or not. People are already shipping these things. So let's not pretend that is a live option the way some people seem to want to go, and figure out how we can respond in the first parts. And so now I feel like we're back into this question of, okay, well, does the gateway do this kind of management? And if so, does that mean that one piece of advice that we could offer is that the resiliency of the network is actually improved if you don't use the internet protocol at those last hops? That the gateway should be managing things, and the little devices themselves should not be using internet protocol. They should be using some other protocol Zigbee or Z-Wave or any of those kinds of things in order to provide the connectivity between this gateway device and the thing. Is that a thing that people want to pursue?
I think the local devices will end up using an array of protocols. They will be using Zigbee. They will be using Bluetooth to talk to one another among like local areas. But there's also nothing to prevent them from directly accessing the internet through IP.
Well, I mean, the idea then is that you could say that an appropriate policy response is to try to discourage marketing of devices that are what we could call them, to be cheeky about it, we can call them devices that are too stupid for IP. We could say, okay, well, this is too dumb and it just shouldn't use that. And you put some regulatory regime in place, you put some certification authority, or that is one of the proposals that people have come up with. And so I personally tend to agree with you that I think that is a hopeless desire, that people are going to come up with this desire to control these things. And our history does not show that we're very good at restricting electronics from reading and hooking up.
Exactly.
So I think that's an important point, though, right? That if what you want to do is say, look, this is a response that we understand what the response is, and we think that it's a doomed project, then that's a valuable thing to say and to inform, what the decisions are going to be, because it constrains the movement of the things we can do in order to improve network resiliency.
I think that's a path that won't be sustainable because people will always find ways to circumvent that. You can, for example, just VPN your home devices to, people will have ways of getting around that, and then they will still get compromised. It will still add to the network load and then take down the entire network. I think a more reasonable approach is to find other ways to contain disasters.
So you're arguing then that instead of trying to make the devices, you're arguing that instead of trying to prevent the pollution in the first place, we should have emergency pollution response everywhere that notices, oh, there's a pollutant coming out there and cleans up. I'm being cheeky, right?
Yeah.
I'm
oversimplifying. But. Yeah, I think I actually do see internet as one of the many transports. And then IoT devices should not rely on the internet. I get your point about that. Is it really an internet connected device? Yes, it is. It is a network device that has internet as one of the many transports. But we should also start looking at broaden the way that devices can interact. Maybe most of the functionalities should be focused on local land interactions, and once in a while connect to the internet for an update, or report some stuff, or report some metrics to the provider that the user thinks is a good idea to report.
I just want to come back to the Catnet approach. So obviously I feel there's value in that. If we can make it easy. So one of the challenges with DHCP and public internet is it's so easy, right? You want to get on the internet, all you have to do is run DHCP, you're on, you do your thing. And the fact that you can connect to a bajillion other devices, okay, it's a side effect, but if we can make it as easy to do something where devices get the connectivity they need, and manufacturers or whoever is deploying something can get that thing to connect back to them with a reduced view, I think that would be a valuable win. And basically anything we can do that helps people implement or that helps people to not put devices in a position where they get compromised in the first place is good. anything that limits local interaction is good. So if we have, you know, a gateway approach where the purpose of the gateway is to limit local interactions only to those that are absolutely necessary, and whether that gateway is in the home or whether some of that interaction comes out, whatever. I mean, I think that's probably a good thing. You know, in the way you kind of think of how microservices are composed. Sometimes you have, you know, basically API gateways that make sure that not too many things are touching too many other things. So, you know, if we're able to do something a little bit like that for allowing home interaction, but allowing it in a way that is allowing the most limited interaction things need, that'd be good. Engineering that is not easy, but at least if we can protect larger classes, then all of the reactive, okay, now there's a bunch of broken things attacking me. Like the more we can protect up front, even if it's none of it's perfect, the easier the other problems become.
So I like this, and I'm just conscious of the time. I guess we were scheduled to end at 4 Eastern, and whatever time the top of the hour is, wherever you happen to be. Half an hour later in Newfoundland, right? I think that the discussion that we've been having is a really solid basis for us to take to the list and try to whittle some of this down a little bit, because it seems to me that we've got two or three concrete things here that are things we need to call on the sort of engineering of the internet to provide, or somehow, you know, we've got to deliver these sorts of things, ISPs or device manufacturers or whoever. And at the same time, there are some recommendations here about, or some potential recommendations about things that I know people are proposing to do, and we have, over the course of this conversation, concluded that they're simply not going to work, and that means that we shouldn't actually chase those things, and we should recommend to people that they put their energies into things that are more likely to work. Those feel to me to be like two threads that I would like to take to the list that we've already set up, the name of which doesn't pop immediately to my mind, but you know, people have their contact information from before, so we use that list, and then we can pick those things up on the list and see if we can nail some of those specific things down. Does that sound like a useful next step? Or anyway, do people think that's not a useful next step? I'm going to put it that way.
I think
Okay,
having some
so
of that in
that
writing would be
sounds
nice.
to me like yeah. I think that's obviously the next thing that we've got to do. We've got to write down some of those conclusions that we've had from today, some themes. So we'll take that to the mailing list. We can have some follow-up discussion on there, and then there may be some specific things that we want to say. Okay, here's a particular topic that we can get you know, people working on it. I note that there is another face-to-face meeting happening, I guess in a week's time, right? So that's another opportunity where we can maybe figure out, oh, well, here are some people who want to work on this thing, and we can get together a little working group to talk about the specific the specific items related to these threads. Because I do, you know, this is supposed to be a multi-stakeholder project, so it's supposed to really be driven by the people who are interested in the problem. So that was everything that I had. I think, given we're running out of time, I don't know if our hosts from ISOC want to say anything more.
No, I thought this was a great discussion. It's Mark Buell, and thank you for facilitating, Andrew. And if people are interested in the event in Ottawa, I think Tom has posted some information in the chat, and we'll send out some more information as it is. Thank you.
Thank you.
Thanks, everyone.
All right. Thanks, everyone. Thanks for your participation. This was great.